Okay, welcome back. We're working on questions 3 and 4 on the stoichiometry practice homework assignment. So question 3 is asking how many grams of H2, and this is still to do with this reaction up here. How many grams of H2 are required to react with 3 grams of N2? So let's write down my given and what I'm trying to find. So they gave me 3.1 grams of N2. It's the only number in there, so that must be my given. And I'm trying to find grams of H2. So if N2 is molecule A, because what I'm given is always molecule A, and my H2 is molecule B, I can look on this map and figure out where I need to go. So here's grams of A, that's where I'm starting. I need to get all the way over here to grams of B. So I'm going to need 3 conversion factors because there's 3 roads. I have to stop 3 times. 2, 3. So I'm going to put my given over 1. So I'm starting with 3.1 grams of N2. That goes over 1. And then I'm going to make 3 lines after that for my 3 conversion factors. So, as it says on the mole map, my first conversion factor is the molar mass from the periodic table. That is always the number of grams per 1 mole of whatever molecule we're dealing with, which is N2. So if you look at the periodic table, nitrogen is about 14, and I have 2 nitrogens because it's N2, so 14 plus 14 is 28 grams per 1 mole. That's the molar mass. I'm going to put that as a conversion factor here, and because I want grams to cancel out, I'm going to put the 28 grams on the bottom and the 1 mole of N2 on the top. Now my grams have canceled out, so I am now in moles of N2, or I'm at the moles of A circle. I want to now get to moles of B, and I need to use the coefficients to do that. So I'm trying to get to H2. So looking back up here at the equation, I need to cancel out N2. The coefficient of N2 is just a 1. So I can just put down here 1 mole of N2. And then I want H2 to be on the top. So I'm going to put 3 moles of H2 on the top. Again, I can do this. This is just saying that for every 1 mole of N2, I need 3 moles of H2 to react with it. So that's what this is actually saying. My moles will cross out. Now I am in the moles of B circle. And I need to get to grams of B. It says I need to use the molar mass for molecule B this time. So since molecule B is H2, I need to find the molar mass of H2. H is just 1, basically. So I'm going to add 1 twice because we're doing H2, so there's 2 hydrogens. So that gives me 2 grams per 1 mole of hydrogen. Now I want the 2 grams to be on the top because then 1 mole will be on the bottom to cancel out that moles of H2. Okay, and then to solve this, I would just multiply across the top. So we'll do 3.1 times 3 times 2. That equals 18.6. And then the only thing on the bottom is 28. So that's going to be over 28. And then 18.6 divided by 28 is 0.66. So the answer is 0.66 grams of H2. All right, and then let's do number 4. Number 4 is different than any of the ones we did in class. So let's still figure out the given find ratio. So I am given 0.8 grams of H2. I want to find molecules of NH3. So let's put the given over 1, 0.8 grams of H2 over 1. Now we're going to call H2 molecule A because I'm starting with it, and NH3 molecule B because I want to end with it. So I'm trying to go from grams of A to molecules of B. So my path is a little different this time. I'm starting right here, and instead of going up here, I'm going from grams of A to moles of A to moles of B to molecules of B. So I will still need 3 conversion factors, but the last one will be different. So let's draw 3 lines. 1, 2, and 3. Now, just like before, my first line is the molar mass of molecule A, which for this problem is H2. So hydrogen, we already looked, it's about 1. So 1 plus 1 is 2 grams per 1 mole. I'm going to put the grams on the bottom so that they cancel out. And then I'll have 1 mole of H2 on the top. Now I need to use next my coefficients to get from moles of A to moles of B. So looking up here, my coefficient of H is a 3, and my coefficient of NH3 is a 2. So I'm going to end up with 3 moles of H2 on the bottom and 2 moles of NH3 on the top. And let's cross out all these things. Okay, now finally the last step that's a little bit different. I need to now get from moles of NH3, that's where I am now, to molecules of NH3. Now this says I need to use the conversion factor 6.02 times 10 to the 23rd per 1 mole, which is Avogadro's number. So that's the number of molecules in a mole. I want moles to be on the bottom, so I'm going to put 1 mole of NH3 on the bottom, and that big number, that 6.02 times 10 to the 23rd molecules, will go on the top. My moles cancel and I will be in molecules. Now, to put this number into your calculator, I'm going to show you how to do that in a second. First of all, let's just enter 0.8 and 2, because we're multiplying by 0.8 and 2. So 0.8 times 2. Now, to do 6.02 times 10 to the 23rd, the easiest way to do that is to do times 6.02, and then don't do times 10. That will do weird things in your calculator sometimes. Instead, push the second button, and then we want this little capital E to appear. That capital E means times 10 to the. So you don't even have to type a 10. So 6.02E, 23 is what I want. I'm going to push enter. That's 9.63 times 10 to the 23rd. And then that is over 2 times 3, which is 6. So I'll just divide that by 6. And that gives me 1.6 times 10 to the 23rd as my final answer. And that is molecules of NH3. Alright, so hopefully that helps you with these problems. Please come talk to me if you'd like to know more, but that is hopefully at least a good refresher, or if you missed class, kind of tells you what we're doing. I'm sure you can now do 5, 6, and 7. They're very similar, just with a different reaction. So good luck!